that's sort of a you know, qualitative sense of what strain is. But what's strain mathematically? So let's go back to our bar. If I pull on this bar and I look at, you know, so I deform it, and this is x direction, and say I just take some arbitrary point and I want to look at what the displacement is as a function of x. So as I pull it, we'll look at the displacement as a function of x. Then if I were to plot that, let's say for now that the displacement is just linear, right? So this is u of x, and this is x, okay? And then I were to ask the question, and let's say we know this slope is m, okay? So then if I were to ask the question, you know, given a point x0 and u0, so given x0 and u0 and m, then what is x1 and u1, where x1 and u1 are some other points. Right. So given x0 and u0 and m, what is x1, u1? Or I'm sorry, what I should say is what is u1 at x1? x1 is the control variable, right? So what is u1? Well, it's just the equation of a line, right? So we can just write down u1 is equal to m x1 minus x0 plus u0. And then let's just say that delta x is x1 minus x0. And so then I have m delta x plus u0. And, you know, u0 is a function of x1, of course. And u1, you know, another way to write u1 would be, u1 is evaluated at x1, but x1 is x0 plus delta x, right? So then I could essentially solve this equation, right, or solve it sort of for m, u1 x0 plus delta x minus u0 and x0, that's x0, divided by delta x is equal to m. And, you know, what do we have here? I mean, this is essentially a change in length over length, right? And then if we were to take the limit of this as delta x goes to 0, then on the left-hand side we have the definition of a derivative, right? We have the definition of a derivative. So this is like delta, you know, partial u, partial x. And of course, we know that visually that's the slope of the line, right? That's m, right? It's m, okay. And so this would be in one dimension, this would be our mathematical definition of strain, right? So it's really just the change in, same thing, it's a change in length over length, it's just in the limiting, you know, in the limiting case. It's the derivative, the slope of the curve.